Hello students, today we will discuss about the second chapter of chemistry of class 11, that is structure of atom. And we will discuss the topic quantum numbers. Quantum numbers, which is very important topic of this chapter. Now we see, first of all we know about the electron, Bohr said that electrons are particles. But after that, what happened when de Broglie and Heisenberg came? They told that no, electrons are waves. These electrons are waves. So what happened after that? Schrödinger came and he expressed these waves as Schrödinger wave equation. Which gives us three solutions. And from this we have got the quantum numbers N, L, M. And the fourth quantum number is spin quantum number S, which though directly didn't come from Schrödinger wave equation, but we'll see about it later on. So students, these quantum numbers N, L, M and S, these are the four quantum numbers. N is principal quantum number, L is azimuthal or angular momentum quantum number, M is magnetic quantum number, and S is spin quantum number. These quantum numbers actually gives the detailed addresses of the electrons of an atom. Means just if we consider that a person who stays in a place, if we look at his address, then what we have to do first? We have to go to search his locality or area where he lives. Then we have to go to the building in which he lives. Then we have to go to the room of the building where he lives. So we'll start the principal quantum number first. Principal quantum number N. This N value actually represents the size of a shell. Means if we have n value is 1, 2, 3, 4, then this one value will represent the question 2L, 3M, 4N, like this. And what we see that if the value of n increases, then what happens? The size of an orbital increases, means size of the orbital or of the shell increases. And we also get the idea of energy of the electron in that orbital. The lower value of n will have lower energy, means energy also increases if you go from n is equal to 1 to n is equal to 4. So this actually principal quantum number gives you the idea of the size and energy of the orbitals. The value of n actually goes from 1 to 3 up to infinity, means integer values goes from 1 to infinity. Second one is azimuthal quantum number. Or angular momentum quantum number. This actually represents the shape of an orbital, shape of a subshell or orbital. The value of L goes from 0 to up to n minus 1, where n is our this principal quantum number. Now if we have n is equal to 1, we will have n is equal to 0. If we have n is equal to 2, n is equal to 0, 1. n is equal to 3, n is equal to 0, 1, 2. So, when the value of n is equal to 0, it will represent S subshell 0, S subshell 1 will represent P subshell, 0 S subshell, 1 P subshell, and 2 D subshell. Similarly, if n is equal to 4, n is equal to 0, 1, 2, 3, then this 0 will be S, 1 will be P, 2 will be D, 3 will be F. So our L value is actually 0, 1, 2, up to n minus 1. So we see here for first shell we are getting only one value of L. For second shell we are getting two values of L. For the third shell we are getting three values of L. So the number of subshells will be is equal to the number of cell. Number of subshell will be is equal to, here only one, is equal to the number of cells. Number of subshells here 2, so number of cells is 2, number of subshells 3, number of cells is 3, number of subshells are 4, so number of cells is here 4. So total number of subshells in a cell will be equal to the value of the cell. So students, here we see L is equal to 0 means S subshell which is spherically symmetrical. L is equal to 1 means P subshell, which is having dumbbell shape. L is equal to 2 means D subshell, which is having double dumbbell shape. L is equal to 3 means F subshell, which is having complicated shape. So by the use of L values, we are getting the idea of shapes of the subshells or shapes of the orbitals. We have magnetic quantum number. M. This actually represents the orientation of the orbitals. Its value goes from minus L to plus L. Means the value of M is minus L 0 dot dot plus L. From minus L to up to plus L, its value goes. So if we have the value of L is equal to 0, that means for S subshell, what we will get? M is equal to only 0, because minus 0 will be 0 and plus 0 will be 0. For L is equal to 1, that is for P subshell we are getting M is equal to minus 1, 0 plus 1. For L is equal to 2, that means D subshell M is equal to minus 2, minus 1, 0 plus 1 plus 2. For L is equal to 3, that means F subshell will get M value minus 3, minus 2, minus 1, 0 plus 1 plus 2 plus 3. So here we are getting for L is equal to 0 only one value of M. For L is equal to 1, 3 values of M. For L is equal to 2, 5 values of M. For L is equal to 3, 7 values of M. Means what idea we'll get from the values of M is that this M is equal to 0 means for S there is only one values of M, means one type of orientation is only possible for the S subshell, which is spherically symmetrical, almost spherically symmetrical. For P subshell, we'll get three different types of orientations whose shape is dumbbell shape. Along x-axis, we'll get Px. Along z-axis, we'll get Pz. Along y-axis, we'll get Py. So these three orbitals we'll get from the value of L is equal to 1 means for P subshell. For this subshell we'll get 5 different types of orientations, means 5 different types of orbitals we'll get, and whose shapes are like double dumbbell shape. And we will get 5 orbitals in case of D subshell. In case of F subshell we will get 7 orbitals. the shape means shape is very complicated, means the orientation of the orbitals for absorption we are getting are seven different types. So here the maximum values of m will be twice L plus 1. Means we see if we put here the value of L is 0, means 2 into 0 plus 1, we are getting 1, means m is only 1 value of m we are getting for S sub shell. If we consider the value of n as 1, then what we will get? 2 into 1 plus 1 is equal to 3. So 3 orbitals we are getting in case of P sub shell. In case of D sub shell, similarly, if we put 2 into 2 plus 1 is equal to 5. So 5 orbitals we are getting, means 5 different types of orientations are available in case of D sub shell. So now N, L, M. L value is actually less than is equal to n minus 1 and greater than is equal to 0. M is less than is equal to plus L and greater than is equal to minus L. So if we have n is equal to 1, then value of L will be 0, value of M will be only 0. So it will be our S sub shell. Here only 1 orbital we will get. If we have the value of n is 2, then we will get the value of L is 0 and 1. So it is S, it is P. So for this we will get only 1 orbital. For this is minus 1, 0, plus 1. So we will get 3 orbitals. For n is equal to 3, we will get the value of L is 0, 1 and 2. That is S, P and D. For S means only 1 orientation we will get. For P minus 1, 0, plus 1. For D minus 2, minus 1, 0, plus 1, plus 2. Means here only 1, here 3, here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we see that here we are getting only 1 orbital in case of n is equal to 1. In case of n is equal to 2, we are getting 4 orbitals, means 1, 2, 3, 4, 4 orbitals. For n is equal to 3, we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 orbitals we are getting. 9 orbitals we are getting in case of n is equal to 3. Means for a cell n is equal to 1, we are getting number of orbitals 1. For n is equal to 2, we are getting total number of orbitals is 4. For n is equal to 3, we are getting 9. Means it is 2 square, it is 3 square, it is 1 square. So total number of orbitals in a given cell will be is equal to n square. Means total number of orbitals in a given cell will be our n square. So students, if we just have one question, how many orbitals are present in case of n is equal to 2? So what we will get? For n is equal to 2, we will have n is equal to 0 and 1. So for n is equal to 0, m is equal to or 0, n is equal to 1, m is equal to minus 1, 0, plus 1. Hence Here we are getting 1, 2, 3, 4, 4 orbitals. 1 and 3. Total we are getting 4 orbitals. So means n square is equal to 2 square is equal to 4. We are getting 4 orbitals in case of n is equal to 2. Students, now we have spin quantum number s, which arises from the rotation of electron around its own axis, which may be either clockwise or anti-clockwise. If we give the clockwise as plus up, we have to give the spin of the electron rotation of anti-clockwise direction as minus half. Means if we give clockwise as plus half, then we have to denote anti-clockwise as minus half. If we give it as plus half, we have to give it as minus half.